All right, let's talk about Java. If you've ever wondered what makes it such a giant in the tech world, you are in exactly the right place. We're going to go way beyond just the code to really get into the core ideas that drive this language, and, more importantly, how understanding those ideas can seriously launch your career. I mean, you see Java everywhere, right? It's powering these massive company systems, it's running the Android apps on your phone, and that's no accident. Its huge success really comes down to this one powerful idea about how software should be built, a kind of philosophy that makes it incredibly strong and flexible. So, what's the secret sauce? Well, at its core, Java is so much more than just a bunch of commands and syntax. It's a whole philosophy, a mindset for building software. It kind of forces you to organize your code in a really clean, logical way. And that structure, that's the secret to its success. It means huge teams can work on enormous applications without the whole thing collapsing into a mess, which is exactly why Java's been a top dog for decades. So this philosophy, it has a name, Object-Oriented Programming, or OOP for short. The best way to think about it is as the master blueprint for everything you do in Java. It's all built on four foundational pillars. If you can get your head around these four, you are well on your way to truly mastering Java. Okay, first pillar, encapsulation. This one is all about protection and, keeping things tidy. Imagine taking your important data and the code that messes with it and bundling them together inside a secure little capsule. That's what we call an object. Encapsulation protects the data from being changed by accident from the outside, which is absolutely crucial for stopping bugs in their tracks. Next, we have inheritance. Now, this is basically the don't repeat yourself principle, and it's a huge time saver. It lets a new class, or a new blueprint, be based on one that already exists, so it inherits all its features. For example, you could have a dog class that inherits all the basic stuff from a more general animal class. It just makes sense, right? It creates these clear family trees for your code and saves you from writing the same thing over and over. Then there's polymorphism, which is a fancy word that literally means many forms. And this concept is incredibly powerful. It means you can have one single action that results in totally different outcomes. So let's say you tell an animal object to make sound. Well, what happens next depends entirely on what kind of animal it is. A dog object will bark. A cat object will meow. Same command, but you get a different result based on the context. And our final pillar is abstraction. Honestly, this might be the easiest one to grasp because you see it every day. Think about driving a car. You use the steering wheel, the gas pedal, the brakes, but you don't need to know anything about the engine or the transmission to make it go. Abstraction is the exact same idea in code. You hide all the messy, complicated details and just give the user a simple set of controls to work with. Okay, so if OOP is the blueprint, then the collection framework is like the set of power tools that every single Java developer has in their toolkit. These are pre-built, super efficient ways to store and manage groups of objects. Let's take a look at two of the most popular ones. First up, the array list. A standard array is kind of like a box with a fixed number of slots. Once it's full, you're out of luck. An array list, though, it's like a flexible, magical bag. It grows and shrinks automatically as you add or remove things. This dynamic ability makes it one of the most useful tools you'll ever use. And here's a perfect, simple example. On the left, we've got an array list with some numbers in it. The task is to remove the element at index 1. Now, remember, in programming, we start counting from 0. So index 1 is actually the second item in the list, the number 20. And look at the output. The array list just takes care of it. It removes the 20 and shifts everything over automatically. No fuss. It's clean, simple, and just works. All right, next up is the hash map. If you ever need to store data and then find it again in a split second, the hash map is your absolute best friend. It stores information in key-value pairs, which works just like a dictionary. You give it a unique key, like a word, and it gives you back its value or its definition almost instantly. This slide shows a classic problem that hash maps solve beautifully. The inclut is just a regular sentence. We can use a hash map to instantly count how many times each word shows up. You can see it in the output there. The word itself becomes the key, and the count, the number of times it appears, becomes the value. This is a super common and incredibly fast way to process data. So we have the blueprint, OOP, and we have the power tools, the collection framework. How does this all get you a job? It's actually really simple. Every single Java job interview on the planet is going to test you on these exact concepts. Why? Because they're not just some academic theories, they are the absolute rock-solid foundation of professional software development. This list right here, this is basically your interview roadmap. You are guaranteed to get questions on these topics. From the basics like data types and loops to the 4 OOP pillars we just talked about, and of course, the collection tools like ArrayList and HashMap. But they'll also hit you on things like handling errors gracefully with exception handling, controlling access, and understanding special keywords. Nailing these topics shows an interviewer that you don't just know how to write code, you know how to think like a Java developer. Mastering Java is all about understanding the nuances. This quote from a real interview prep session is a perfect example. A great developer doesn't just give an answer to a vague question like, tell me about data types. They clarify it first, asking whether the interviewer means object types or primitive types. That shows a much deeper level of understanding. It shows you're thinking about how Java actually manages data and memory, and that's a huge deal. And really, it's this deep-rooted structure and reliability that explains why Java has stuck around for so long. It wasn't just some fad. It was designed from day one to be a serious tool for building serious, long-lasting software. All of Java's famous strengths are totally connected. That famous write once, run it anywhere promise, that's possible because of its core architecture. Its reputation for being secure and robust, that comes directly from its strict, object-oriented structure. See? It all traces back to that central philosophy of building software in an organized, protected, and logical way. So, in the end, Java gives you more than just a language. It gives you a framework for thinking. It hands you the blueprint and the power tools to build incredibly complex and reliable things. The only question left is, what are you going to build with it?